In this lesson, we're going to practice on how to use F equals to MA. Okay, so this is a question. Take some time to look at this. Okay, how to solve this is that we know that acceleration is the gradient of the velocity time graph, and F net equals the mass times acceleration. And when acceleration equals 0, F net of course equals 0, or when acceleration not equals 0, F net is not equals 0. So let's look at region 2. Okay, region 2, there's actually no change in velocity. So no change in velocity means acceleration equals 0, which means that net force equals 0. So the only two possible cases will be A or C. In region 1, there is some acceleration because there's a change in velocity. So which means that the net force is not equal to 0. So the only possible options that fit this case would be C. Okay, and how do we calculate 1? Is that you can actually calculate by calculating acceleration with final velocity minus initial velocity divided by the time taken. So having a value is final velocity is 10, initial velocity is 0, and 20 seconds. So by calculating acceleration 0.5, and knowing that the mass of the object is 2 kg, you just substitute in 2 times 0.5 equals to 1 Newton. Next question. Okay, a woman pushes a cart of mass 4 kg and has a horizontal force of 20 Newton and accelerate by 2. So what is the frictional force? So by drawing a free body diagram, it's easier to solve. So there's a push with 20 Newton and there's some unknown frictional force. And take note that F net in this case of course is push minus the wave friction. Again, we make use of F equals ma, and by substituting this F net is equals to force equals to this. Okay, so you find that we'll have this equals to mass times acceleration. So it's just simply 20, which we know, minus and substituting 4 multiplied by 2. And by rearranging the equation, we get friction equals 20 minus 8, and you get 12 Newton. So in this case, the answer is also C. Okay, let's get something more complicated. You can pause the video. Okay, so right now they are supposed to draw a free body diagram of the engine and the trailer separately. So let's just draw for a trailer. Of course, for a trailer, there's always a weight, and since it's not floating in the air, you'll have a normal force, which is equivalent. There's some air resistance as stated over here. So air resistance is 5 Newton per 1000 kilo of the trailer. And there's what is pulling is not really a lorry, but actually the tension created by this tow bar. So it's actually this force that's pulling for now. And let's draw for the truck or the engine. So there's weight and there's as normal. There's air resistance, okay, which is slightly different. It's 10 Newton per 1000 kilo. And of course, there's this forward driving force. There's one more force that is actually holding the truck back, which is actually the tension. In this case, the tension is pulling the truck backwards. Okay, so this is the free body diagram. How do we solve B? It's actually the following. It's broken down into, we use the trailer free body diagram to calculate what is the value of tension. Then we know that the tension in trailer is actually equivalent to tension in truck. And after that, we use the tension in truck to try to calculate the forward thrust using the truck free body diagram. Okay, let's try solving it. We are not interested in the weight and the normal, okay, because we are interested in the left and right motion. So in this case, the F net is mass of the trailer. Okay, I take note, mass of the trailer. We are talking about trailer, so it's only mass of trailer multiplied by acceleration. So however, F net is of course tension, which is pulling forward, subtract away air resistance. Thus, tension minus air resistance equals to your mass times acceleration. Okay. And by substituting the known values, we know that air resistance is 5 because it's 5 Newton per 1000 kilo, and this 1000 kilo, and mass is 1000, and the acceleration is 0.1. Okay, so everything fits into place. By solving for tension, you should be able to get 105 Newton. Let's solve for the forward thrust force. So again, we are not interested in weight and the normal. and Fnet, the mass of the truck. Okay, this time around is the mass of the truck because we are talking about the truck. But however, for a truck, the Fnet this time around is forward thrust, which is going this way. You subtract away the air resistance plus the tension. Okay, so this is what it meant. And again, go through the same process. This is your Fnet equals to mass times acceleration. Substitute in the value, and this time around air resistance is 10 Newton per 1000 kilo, and since it's 5000 kilo, that's 5 times 10. And the tension was before, which we calculated was 105, and then you have 5000, which is the mass of the truck, and the acceleration. And by substituting and solving for this, you should get forward thrust is equals to 655 Newton. Okay, that's all for now. Please subscribe and support my channel. For my other physics video lesson arranged according to topics, please visit my blog at boringphysics.wordpress.com. You can subscribe to my channel to be informed when I upload new physics video lessons. Thank you.